Okay, so we're going to keep going on 3.2. Now we're going to see some examples. So these were just some things to remember. I'll let you look over those. If you need to pause me, go for it. So let's go to this first example. It says first find the two x-intercepts. Okay, so remember x-intercepts are going to be where y equals 0. So I'm going to set my equation equal to 0. This is just old algebra 1 stuff. So we have our zero product property, which says that when I have multiple things set equal to 0, I can set them each equal to 0. This only applies when they're set equal to 0. Okay? Well, -3 will never equal 0. I don't have to worry about that. So I'm going to take my next factor, x equals 0. Well, that was easy. And then I'm going to take my next factor, x plus 1 equal to 0, which square root of x plus 1 equals 0. So x plus 1 would be 0, so x equals -1. So my two x-intercepts are at 0, 0, and at -1, 0. So it says, show that f prime of x equals 0 at some point between the two x-intercepts. So basically I have my interval from 0 to -1 that I am talking about. Okay, so that's like my A and that's like my B. Well, I know that if I found f of B minus f of A over B minus A, we already found that this is 0 minus 0 over -1 minus 0. So I get out 0 because these two values were equal. Okay, so when f of B equals f of A, I'm going to get that secant slope of 0. So what are we thinking of here? Extreme value theorem, mean value theorem, or Rolle's theorem? Yeah, I would think of Rolle's theorem. So Rolle's theorem says that if I can meet some conditions, so is it continuous on the closed? So let's see. What are my only stipulations here in the domain is that this guy has to be greater than or equal to 0. So x has to be greater than or equal to -1. And all of those work. So I am continuous. Oh, you know what? Oh my gosh, I'm crazy right now. Can I write an interval in order? Really, DeRose? Really? Okay, so let's make sure we write this in order. Yeah. Okay, first day back from a couple days off, right, for me. So it would be -1 right here and 0 right here. Hope you weren't using pen like me. So this is continuous from -1 to 0. And that's true. And then the second part is that it's differentiable on the open interval from -1 to 0. So if you think about this going on, can you find the derivative? So we'd have to do a product rule. So we have our first and our second. First times the derivative of the second times 1 plus the second times the derivative of the first. Let's clean that up a bit. So I'm going to pull out a 1/2 x plus 1 to the -1/2. That would be -3x. Oh, hold on, let's pull out that -3. So that would just be x, pulled out that, okay, plus x plus 1 to the first times 2, because I took out that 1/2. So let's see. I have -3 times, this would be 2x plus x is 3x, plus the 2 over the 2 times the x plus 1 to the 1/2. Okay, so all the places where this would not be differentiable. So it wouldn't be differentiable, that's f prime of x. Let's see. At -1, that would not be differentiable because I'd have a denominator down there of 0. So that would not be differentiable. But everywhere else, great. greater than -1, that denominator is fine. So it is differentiable on the open. So just note, it's not differentiable on the closed, but that's okay. It just has to be continuous on the closed. And I saw that f of b equaled f of a. Okay? So, by the Rolle's theorem, there exists a c belonging to that open interval from -1 to 0 such that f prime of c equals 0. Pretty cool. All right. You want to look at that graph? Let's look at that graph. X second square root x plus 1. Let's don't need that. And let's go ahead, let's go in because we're kind of, let's get it a little bit zoomed in. Because I didn't zoom in too far. Okay. So here at -1, my graph is kind of a little bit sketchy. I might need to change the pixel stuff a little bit. But here I can see at -1, I am at 0, and at 0, I am at 0. It is smooth and continuous on that open interval. And when I talk about the slope of my secant line going on between the two, that slope is 0, and sure enough, I found another slope. So my c would be right there at the max. And if I wanted to find that c, let's see, the max value. That's too far left. So the max, it looks like, is at -2/3. Okay? So that's going to be Rolle's theorem. So basically you just said that because of all of this, you are guaranteed a max. And sure enough, there it is. Alright, let's look at this next one. Determine whether Rolle's theorem can be applied to f on the given interval. If Rolle's theorem can be applied, find the value c that guarantees the theorem. Okay, so Rolle's theorem, 3 things. Continuous on closed, differentiable on the open, and f of b equals f of a. So are there any restrictions for continuity? So I'm just kind of looking at this right here. I could rewrite it if you really wanted to. That's the cube root of x. I don't know if that helps you in your thinking process. But here, since it's odd, I can put anything in for x. The only restrictions would be when I have an even root. So there's no restrictions. What about differentiability? Well, let's take the derivative. All right. Okay, so here again, if I wanted to kind of think of that, that would be the cube root of x squared. So my only restriction here is that x cannot be 0. Okay, so that's my only differentiability. So let's talk about our 3 conditions then. Is it continuous on the closed? It sure is, because there's no restrictions at all. It's continuous everywhere there. Is it differentiable on the open? It sure is. The only restriction I have is on the closed part of it, so we're good there. And does f of b equal f of a? Well, let's go find out. F of 0 is going to equal, so this is f of b, does it equal f of a part? So f of 0 is 0 minus 0, which is 0. And f of 1 is 1 minus 1, which is 0. So all of those conditions are true. So then I know that there exists some c. So there exists a c belonging to 0 to 1 such that f prime of c equals f of b minus f of a over b minus a. But since b and a are equal, I know that that's going to be f prime of c equals 0. And now it says, hey, find all those values. Okay, so let's go do that. So I'm going to set f prime of x equal to 0, and we said that was 1 minus 1/3 x to the 2/3. Now when I do this, when I do this, I'm going to go ahead and get a common denominator because I don't want to lose out on any of my values by making it too easy. So I'm going to go ahead and get that common denominator going on. So this would be 3x to the 2/3 minus 1. Yes? Yes. All right. So where it equals 0. Now it doesn't exist. Just a little side note. F prime of x doesn't exist when x equals 0. Okay, but now to actually solve, I can set my numerator equal to 0 to find where I'm going to equal 0, not just the critical numbers, but where it actually just equals 0. So I say 3x to the 2/3 minus 1 equals 0. 3x to the 2/3 equals 1. X to the 2/3 equals 1/3. X equals 1/3 now raised to the 3/2. But when I take a square root, I have to plus or minus it. Hey, I'm recording. What's up? Oh, thanks. That's sweet. My sister-in-law just stopped by to say hi. Okay, love you. Okay, so whenever you have a root that's even, you have to do the plus or minus. So let's see. If I cubed it, that would be 1, 3 cubed is 27, still raised to the square root. So x is plus or minus the square root of 1/27-ish, okay, which is approximately second square root of 1 divided by 27, plus or minus 0.19245. Okay, sorry, I'm kind of squeezing into this guy's room. So, I only want, though, my c to belong to the open interval 0 to 1. So in this case, my c is going to be approximately 0.19245. Okay, or exactly just the positive square root of 127. Okay? All right, let's look at the next one. Now, before I even start this, do you think, oh my gosh, I want to simplify that? I don't even want to read the rest. I just look at this and I say I have an exponent of 1. I'm simplifying that. Then I'll go read it. Okay, so it says, determine whether the mean value theorem can be applied to f on the given interval. If the mean value theorem can be applied, find the values of c for the theorem that the theorem guarantees. Okay, so let's see, mean value theorem. I have to be continuous on the closed. And looking here, no restrictions, no even roots, no denominators, nothing, no restrictions, so we are